So now that I'm recording, let me again state you obviously have the test tomorrow, and it covers just the word problem part of 2.10, the optimization. So like on that review, 3.1 through 3.6 and 3.8, and then 2.8, so not 3.11. And it's always that looks like more than it is. Pretty much 3.1 to 3.8 are just triple integrals, either in rectangular or polar or coordinates, and I forgot double integrals. So double or triple integrals, either in polar coordinates or rectangular coordinates or spherical coordinates, and then cylindrical, which is an extension of polar. So, for example, the volume, all you do is integrate 1. To get the mass, you just integrate the density function. So just like in the other ones, you're given a function that you want to integrate, it's just called density function instead of a more generic term. In terms of the actual test, the way it's going to work is like the last test, is I'll make it available sort of at 1:30. What I'll probably do is, as usual, make it really available at 1:25. That way, give a little leeway. So if I mess it up, so I can fix it by 1:30. So it'll be available around 1:25. I will be on Collaborate Ultra. So if you have any quick questions, I will also be on Zoom. And that is if you have either a more involved question or just one that's harder to ask without actually speaking. So for that, what you will do is you will not be in there on Zoom in general, but if you come up with a question, you'll log into Zoom, ask the question, log out, and then that way someone else can come and ask a question. So Collaborate Ultra is for the basic questions, and Zoom is if you have either a more specific or more elaborate question. And also, as usual, tomorrow from 11 to 1, I have the office hours on Zoom. So it will be a different one, which I think I put in the email. Okay, so let me talk about the two errors. So if you downloaded the answers fairly early yesterday, after they first came up, there are two errors two places I messed up that people have found so far. One is a fairly stupid one in problem 5. So in problem 5, in the original version, I did the limits of the inside integral from 0 to 4 minus 2x minus 2y. And since that integral was in terms of y, pretty obviously that was wrong. And it was supposed to be 0 to 4 minus 2x minus 2z. And then everything else beyond there, okay, it just looked weird because of that thing. So kind of a silly error. The other one is a bit more elaborate, which I want to talk about, which is number 7. So we had this, and the two pieces were that this is a sphere, this z equals r. If you put stuff in, you just get an angle. Since the last is d theta, the outside integral isn't going to change because we're just going to rewrite this in terms of d rho, d phi, d theta. So that's not going to change anything. And so I did this, and you're going to, after I write it, so this is what was on the original answers. So this is what I put in for the original answer when I wasn't thinking. So why is this wrong? thought I corrected, but I may not. So it works out. So it looks like this is kind of straightforward, right? I changed the r squared to r squared. And then I changed r as the cone, so it just becomes the angle, which we get here. This is the sphere of radius squared of 8, which is why we get that, and there are no restrictions. But, as Cyrus said, really, if you think about it, this was r and then times our usual r times r dr d theta. So therefore, this, which remember comes from, this is the row r, we're only really adding a row. So this already involves one of, this r, which means, and I can't erase it, but that should not be there, right? Because this is r times the r dr d theta, so it becomes r times the rho squared sine phi of the rest of it. Oh, so that's this. So the bottom limit is equals r, which when I do the conversion, I get that. Divide through, I get the tangent of phi is equal to, so these are all supposed to be phis. Tangent of phi is equal to 1, and that's true when phi is equal to pi over 4. So this, in words, what this inside limit is telling us is we're going from the cone to the sphere. So it's the, we're looking at the thing between the cone and the sphere. There is something to check, which is we do have to check that, because this 2 isn't obvious, so there's sort of something to check, but you know in the background it sort of is okay, which is that we have to set them equal. So if I set r equals the square root of 8 minus 8 squared, 8 minus r squared, sorry, then it gives me 2r squared is equal to 8, which gives me r is equal to 2. And that's where that 2 comes from. So in other words, that 2 is nothing new. It's just part of where the cone hits the sphere, kind of like the one we did yesterday. So we notice that this r, because it's in polar coordinates, really is only one as the actual function, and the other is what we get from the conversion from dy dx to dr d theta. And then when we convert from dz dy dx, we get the rho squared sine of phi. Okay. So in some ways you have to think about, when you're converting, you have to think about how it would have been in the original one. So that I messed up, so I went to look at it. So any other questions on this? I thought I had changed where I got rid of the squared here, but maybe I didn't, which is why it's a good idea for me to go over it. When I email it to myself, I still have the one that's squared in it. So I guess you'll let me know at some point. So this is the actual answer without the square. Okay, so any questions on this? Okay, so let me also do, so in some ways, this is like test one. There are a couple I want to look at, and then the rest of the time we'll be going over questions you have, which means it might be a short session. So the other one we definitely haven't done. So yesterday we did a bunch of triple integrals. So we've been doing triple integrals for a little while, but we've only done the one from 2.8. I think we did one yesterday, sort of one yesterday. So let me do one like none, but just so you have another example. So let me change it and ask the same questions. I can also make it sort of a simple one. regular. So let's find the tangent vectors at, say, a point 1, 2, and show that the parameterized form of the function is regular there. So we take the derivatives, get the tangent vectors, and as I said, made it, in this case, fairly simple. Purpose. So there are the tangent vectors at 1, 2. To be regular, what do I need to be true? Really, two main things. One, we get, in this case, fairly obviously. So what are the two things we need for it to be regular? Oh, I changed the function. So to make it on purpose different than what's on a test, I changed it so we have a second example. So yes, so as a few people say, we need it to be differentiable. That's pretty obvious, right? This is a really easy function. There's no place where that function or its derivatives isn't going to work because we have pretty simple functions. So that part's easy. And the second part, so we don't really have to state that, is once we actually show that we can get those values, that's pretty much showing it's differentiable. But the second part is we need to show that they're linearly independent. And how do I say that? Or show that? And there are two ways. One way that you should be doing well. Right, so they're linearly independent if they're not parallel. So since the derivative with respect to r is obviously not a constant multiple of the derivative with respect to v, pretty obviously because it zeros in different places, that says they're not parallel. And that says that they are linearly independent. So between just getting the tangent vectors and showing that they exist, and then showing that they're linearly independent, that's what you need to show to show that they're regular. Okay, so here I can actually, it's the same as the last one, so just so I can fit it. So part B is now let's find the tangent plane at 1, 2. And I'm not going to write that because I want to be able to fit it in. So if I want to find the tangent plane at 1, 2, then what else do I need? I just need one little more thing. So I need the value. So in some ways, pretty similar to when we were getting tangent lines and tangent planes in a different way, which is plug it in. So if I put in 1, 2, I get 4 and 1 and 4. And then the tangent plane is the x, y, z. So the whole general thing. And then that's equal to that point plus some variable, whatever you want to call it, using 1, and it doesn't matter which order, and a separate variable using the other tangent vector. So this is the way we can get tangent planes using two vectors that are parallel if they're linearly independent. A little thing, just because I think t is usually used for time in the text, when he writes it out, he uses a's and b's for the variables. So a times 420 plus b times 204. As I said, it doesn't matter what you call the variables, as long as you call them something. Obviously, you can't call them x, y, and z, because those are already used. So this is what is on the test from 2.8. Pretty much just those two questions. Check to see if it's regular at a point and find the tangent plane at a point. As I said yesterday, in some ways the reason I want to put it on is that way you'll have one fewer triple integral. No, so something's gone wrong. So for example, suppose we had an equation of a line, then that doesn't really make sense to say it has a tangent plane. Or even worse, suppose we did a cone and we're trying to get the tangent plane at the point. Well, there's a problem for a different reason, which is that the derivative doesn't exist there. So you cannot, and that's, so something kind of weird is happening there. Either something isn't differentiable, or just, as I said, it doesn't make sense. So you will not see that tomorrow. So any other questions on this? Okay, so let me do the one thing that isn't on the test, 3.11, as I said I would, which will take about 3 minutes. So if we want to find the surface area of this thing over some particular region, so let's see. So you'll remind me once I erase this. So the derivatives are 2v, 2u, and 0, and 2, 0, and 2v. No, so it'll be, since we haven't done many, it'll be just like the question I just erased. I will give you a parameterization, and then you'll do it. So pretty much it's just one little thing, which is this is going to be the double integral over the region. And I just give it the region to you, basically. Only you have to remember which order to do it. And then the magnitude of the cross product. And the dA is just whichever order you want to do. The little weird thing is that the cross product here is now functions, which is a little bit different. Because we're not going to get numbers back, obviously. And here you'll double check me. So we do the usual thing, I times this matrix, j times the first and third row, which is 4b squared, and then minus, and then first two, which is this 4u squared. Let me stop there for a second. So you can kind of double check. Since it's not on the test, I'm not going through all the steps, just keeping it in your mind when we really do it again next Monday. So is that okay? And when I say is that okay, I don't mean to understand it, but is it correct? Yes, okay. So we do the double integral. Obviously, since we have the u in terms of a function, we want to put that as the innermost. Now will give us the limits for that. And then how do I get the magnitude of a vector? So the magnitude of vector is the square root of the sum of the squares. Just barely thin. Obviously, you don't really need the negatives because we're going to square it and they're going to go away, but just to show where everything's coming from. And similar to distance from Calc 2, that often is not an easy integral because we're dealing with square roots and squares. And so even more than usual, for this type of thing, you'd just be asked to set up the integral. So I'm looking at it, I don't think anything nice happens with it. We can take out the 4, but that's not helping. So yeah, so usually we just set it up. So this is not on the test. So knowing that, any questions on this? All right, so those are the only ones I wanted to look at. The ones I made little mistakes on, and then another version of number 9 because we've only done really the one example besides the one that was on the review. So from now, the kind of the usual thing. Any ones that you have questions on? And like the other test review, the dual type questions, either something you have is one that's on the review that you have a specific question on, or which might be harder, one where you want to look at one that's similar. Sure. So this one, if I make it up, won't be great, but let's suppose, and in theory, there are the 2 versions I can do it, but we haven't done too many, which is, if you remember from Calc 1, there are kind of 2 ways we could do kind of a fence type one, and it'll be a box type one for tomorrow, is either you can fix the area and ask to optimize or minimize the cost, or you can fix the cost and ask to maximize the area. So same with the box, you can either fix the area and ask to minimize the cost, or fix the cost and ask to maximize the area. Second one's kind of a pain, so it'll probably be that first type. So let's suppose we want a box with a fixed volume. And since I'm just making up, it probably will not come out nicely, but that's okay. We want a box with a fixed volume of 10. And let's assume if there is no top and bottom is $2 per square foot, and sides, kind of a run-on sentence, and sides are $1 a square foot, then find the dimensions at minimized cost. And just so we're all working with the same values, when I ask you what is the volume and so on, let's call this X, Y, and Z, say. So here there's no cover, so there's nothing on the top. Sides are each $1 a square foot. The bottom is $2 a square foot. So what is the volume of this thing? Right, so on the one hand it's 10, and the other side it is X, Y, Z. So we'll be able to use that to get rid of one of the variables. And might as well do it now that it matters. So for example, And of course, it doesn't matter which variable we solve for. For the cost, what is the cost, for example, of the front, which will be the same as the cost of the back? So we'll have 2 of xz's, and there's a 1 in there. So I'll put the 1 just to make it obvious that we're putting in the cost. And see if we can as the other ones. Then we have yz, we have 2 of those. And we have 1, that's going to deciding if I want to change things, because since those are all the same, what's probably going to happen in terms of solution? Right, it's going to be x, y, and z are all going to be the same. So let's change this to, instead of about 2, let's make it 5. Just make it something different. That, since I made it up, ended up being an easy one. Let's change it so you actually have to do some work. And then when we plug in, so if I plug in z is equal to 10 over xy, I get 20. The x's cancel, and I get out divided by the y. For the next one, the y's cancel, and I get 20 over the x. And the last one, I leave it as 5xy. So I plug in. And then from there, it's similar to what we had before, which is take the 2 derivatives. Derivative with respect to x is minus 20 over x squared, and then plus 5y. Derivative with respect to y is minus 20 over y squared plus 5x, also equal to 0. So this one, I'm kind of running out of room, would give us y is equal to 20 over x squared, 20 divided by 4. So 4 over x squared. Save some space. The other one has x is equal to 20 over y squared. Which if I plug in this, I get y to the 20 over 16, which of course is 5/4. I'm not sure why I didn't simplify. X to the 4th. Oh, wait. Oh, we had 5. Thank you. I did it again. So 5. So I do it as that. Thank you. Oh, geez. Wow, my bad. So 1/4. And then, of course, I can cross multiply to get 4 is equal to x cubed. So this is cx. Solving for y in terms of x, I get this. This is my cy. I really messed up, but if you do it, you get x is equal to 20 over y is equal to 4 over y squared. So this gives this second one 4 over y squared. And then if I plug one into the other, doesn't matter which way. So I plugged y equals 4 over x squared into this. And then that gave me this. And I divided through by the x, divided through by the 1/4. And obviously this is not a nice number, but whatever it is. And once I have that, then I can plug that into, for example, the y to get y is equal to 4 over 4 to the 2/3, which sort of, as you might guess, is the same as x. And then z is equal to 10 over 4 to the 2/3, whatever that is. And then, so plug that in to the y equation and the z equation to get the other two variables. I just kind of run out of room so I can't really fill it in. So pretty much we haven't done many, so it'll be like that. as I said, the other way you could do this, but I won't tomorrow, is instead of fixing the volume, I could fix the cost. The idea would be similar, it's just slightly more complicated, which is you would set this equal to the constant. You could then solve for one of the variables in terms of the other two, and then plug it into the volume. I would say don't do it because remember, I'm mostly not grading it. So if I say, yeah, I'm okay with that, and I would have graded okay, the TA might not notice it and so might take something off. So I would say even if you notice it, you probably want to go through all the steps just to make it easier for both of us. Because I would still give you the points back, but you'd have to look at it, see what he said, send me an email, we'll talk about it, and then I would give you the points back. So just keep it simple for both of us. Just write all the steps. Yes, but I'm just being partially lazy and partially because I didn't have room, which is, so we got X, we would then plug into the Y and plug into the Z to get the other two numbers. I just don't really have room to put them in to show you what I'm doing. Okay, any other questions on this one? Okay, so, oops, sorry. So if the cost instead of, right, and it, but well, so it would be the kind of easy variation will be the same exact setup, but where there's no top, the bottom is $5 per square feet, the sides are $1 per square feet. Then if we want the cost to be $500, then what would the dimensions be to maximize volume? And so what you would do is whatever I just said, set equal to 100. You can see it's going to be kind of annoying. You would then solve for one of the variables in terms of the other two. So for example, we could solve for Z. And so you would subtract the 5xy to the other side, factor out the Z to get Z times parenthesis 2x plus 2y, and therefore Z is equal to the 100 minus 5xy divided by 2x plus 2y. And then you would plug that into the other equation. But you can see that that's going to be a bit more annoying because the denominator is not going to cancel nicely. So the derivative is going to be a bit messier and I'm not going to put that on the test. So in theory, you could do it the other way. It just tends to be slightly messier unless really, really work at it to get something that works out nicely. So as I said, tomorrow it will be this form because we haven't done very many. I guess in theory, the other one that could do is we also did one where we minimized distance between things. But again, I think we only did the one example of that, and that was a couple weeks ago. So this time. So keep it simple for you for tomorrow. It'll be one like this, just pretty much with different numbers. And what I might do, just so they are all different, I might make it so, for example, the back costs something different and the bottom costs something different and the other sides are. That way we'll get variables that are all distance that are all different. Also, I can't guarantee it, but I'll try to make it so the answers are integers. Try to make it so they work out. All right, so others, they have questions on it. Sure. So 5 is, in some sense, for the triple integrals, the nicest one. So we have this. If you draw it, we get this, and then it's the solid between that triangle and the coordinate axes, coordinate planes. And the reason I call it one of the nicer ones is you'll notice that the projection into any of those coordinate planes is pretty easy. You can actually just see them, right? So the projection into the YZ plane is this triangle. The projection into the XZ plane is this triangle up here, and into the XY plane is this triangle here. So all the projections are fairly nice, so it doesn't matter which order you do it, as opposed to some of the other ones we've done where the projection in one form is much nicer than the others. So if we did it, dz dy dx, and what was the function? 2x. And what we'd be asking is, what is the bottom function? What's the top function? So the bottom function will be 0, although in this case it's the xy plane instead of the xz plane in the order I did it. And it will mean that when we do it, we have to solve for z in terms of the other two. So that would give us that. So that. And then we'd have the projection. The projection would be this triangle, not to scale, because this is the point 2, 0, and it's the point 0, 4. And this is now, you can see when z is equal to 0, so it just becomes 2x plus y is equal to 4. So therefore, what would be the middle limits? And the outside limits would be 0 to 2. So yeah, this is one of the ones where really any order is pretty straightforward. The only reason I started with dy is that way I didn't get fractions. But yeah, it doesn't matter. Any others? So kind of like test one. So why don't I say we're basically done? Let me remind you of two things. One is the TA does have office hours this afternoon, and you can ask him about the quiz if you want. And then tomorrow morning from 11 to 1, I have the quiz. I also have office hours, geez. And then the test will open up at 1:25. As I said, that gives me 5 minutes, so if I do something stupid, then I can fix it by 1:30. The test, you have until 3:10 to then hand it back in. And I will be on both Collaborate Ultra like this, where you can just come in and you can ask fairly straightforward questions. And then I'll be on Zoom, and I sent the link to you in the email. And for that, you're in general not going to go into Zoom, but only go if you have a more specific or more detailed question. You'll come and ask the question and leave, and then someone else can come in and ask a question, leave, and so on. So you might have, when you come in, you might have to wait a little bit if someone's already there. So as always, if you still have questions, stick around. Otherwise, we're mostly done. So I'll keep recording for a little while, so if there are any more specific questions, but he said he would have it done by 9 p.m. today, which is too late, but as I said, if you want, you can talk to him. So also for the quiz, remember, if you have a question, if you looked at the answers and you're not sure how something worked, and you want me to look at your answer, I will do that. So send me an email. I don't want to grade all of them, but yeah. Oh, so for this one right here. Right, so the lowest quiz grade is dropped. Yes, okay. Oh, so here I just put it in. So I had the equation. Since the projection is its biggest when z is equal to 0, I just put in z equals 0 to get the 2x plus y is equal to 4. And since the outer one is x, right, we're just going from there to there, which is 0 to 2. Since most people are leaving, I'm going to stop recording, but stick around if you have questions.